Alright, so first I want to start off with telling you how coding categorical predictors can be accomplished, and I want to explain the data that I chose. So the data that I have chosen has a binary categorical outcome, which is admissions into graduate school, and the continuous predictor is GRE scores, and the categorical predictor is rank, for which I dummy-coded 4 ranks into 3 dummy-coded variables. For this module, I chose to use dummy coding to code for the categorical predictor in my dataset, which is rank of one's undergraduate college, which is on a scale of 1 to 4, with 4 being the highest rank. The dummy coding enables us to test mean differences between groups, and the differences are tested between the base, where I chose rank 1 to be the base, and each subsequent group. For the first dummy code, I coded rank 1 as 0, rank 2 as 1, and rank 3 and 4 as 0. For the second dummy code, I coded rank 1 and 2 as 0, rank 3 as 1, and rank 4 as 0. And then the third dummy code here, I coded rank 1, 2, and 3 as 0, and rank 4 as 1. So for the multiple regression correlation, I have 4 predictors. I have 3 dummy-coded variables that are categorical and binary, and then I have 1 continuous variable that is GRE scores, along with the binary outcome variable. When looking at the output for the linear regression, the R-squared value here should be close to 1, and our value is 0.117, which means that 11.7% of our variance accounts for Y. We can also look at the VIF and conclude that multicollinearity is not a problem, because when we have collinear predictors, the VIF increases and then the standard error increases. But all of our standard errors here are relatively low. And also, when we look at the t-scores, as you can see here, for the 3 dummy-coded variables, we see that they're all negative, which is bad and suggests that there might be some multicollinearity between the dummy-coded variables and the outcome admission. The t-score for GRE is not negative, as you can see here, which suggests that there is not multicollinearity between GRE and the outcome admission. As for the B values, you can see here, it's how much increase we can expect in Y for every incremental increase in X. We want our B's to be as close as 1 as possible, but all the B values for the dummy-coded rank variables are negative, which leads me to think that there is probably multicollinearity between the dummy-coded rank variables and the admission variable. As for the B value for GRE, it's not negative. It's positive, but it's not close to 1, which is not good. And bearing all of this in mind, each predictor seems to be significant at the 0.05 level, and thus leads me to reject the null for each predictor and the outcome variable when using the linear regression analysis. But it's important to note that there might be some multicollinearity with the dummy-coded predictors. So when looking at the diagnostics for the linear regression, the histogram shows that the data appears to not be normally distributed. The data seems to be positively skewed here. The PP plot also tests the normal distribution assumption, and the data does not look normal, and it doesn't seem to follow the line of best fit. So with that, I'm concerned that it also violates the normal distribution assumption. And as we talked in class, and as shown by this graph and plot, linear regression doesn't seem to do well with categorical predictors, so it's best to use a logistic regression when dealing with dummy-coded variables and a binary categorical outcome. It's important to note that the standard linear regression is part of the general linear model, or the GLM, whereas logistic regression is part of the generalized linear model. The standard linear model is normally used when there is a continuous predictor, and the logistic regression model is used when there is a categorical predictor, which is what I have and why I'm going to conduct a logistic regression analysis with this data set. So, a binomial logistic regression predicts the probability that an observation falls into 2 categories of a dichotomous dependent variable based on 1 or more independent variables that can either be continuous or categorical. According to James Press and Sandra Wilson, the logistic regression model is formulated by relating the probability of some event, which in my case would be getting admitted into grad school, that is conditional on an explanatory variable, which would be GRE scores and the rank of one's undergraduate college. So in order to get the total law of probability, we have to take the natural log, which is your b values, and take 1 and subtract it from that b value. The exponential value, b here, is the odds ratio, and it determines whether or not the natural log will increase if it's positive and decrease if it's negative. So, to start, for the GRE predictor variable, we would do 1 minus 0.004, which equals 99.6%. This means that for every single point increase in one's GRE score, the odds ratio of getting into grad school increases by 99.6%. For the first dummy-coded variable, it's important to note that the ranks were coded as 2 equals 1 and 1, 2, and 3. 1, 3, and 4 were coded as 0. So for every single point increase in one's ranking of their undergraduate college, the odds ratio of getting admitted into grad school increases by 27.8%. For the second dummy-coded variable, the ranks were coded as 3 equals 1, and 1, 2, and 4 were coded as 0. So for every point increase in one's undergraduate ranking, the natural log of the odds of getting into grad school increases by 1.488, or 48%. For the third dummy-code variable, as you can see here, it's important to note that the ranks were coded as 4 as 1, and 1, 2, and 3 as 0. So for every single point increase in one's undergraduate college ranking, the natural logs of getting into grad school increases by 1.778, or 77.8%. So based off of the dummy codes, the first dummy-coded variable has rank 2 coded as 1, which is whether or not one gets admitted if their undergraduate college is ranked as a 2. And the percentage of people who get admitted if their college is ranked as a 2 is 27.8%. The second dummy-coded variable has rank 3 coded as 1, and the percentage of getting admitted into grad school is significantly higher at 48.8%. The third dummy-coded variable, when one's undergraduate college is ranked as a 4, one's chances of getting into graduate school is even higher at 77.8%. So the higher rank of one's undergraduate college, the higher their chance one has of being admitted into graduate school. And the higher the one's GRE score, the higher the chance one has being admitted as well. So when looking at the interaction term here, for each rank in GRE, the first rank, rank 2, which is how it's coded, in GRE is not significant, as you can see here, which makes sense because the lower the rank of the college, the less of the probability of getting admitted into graduate school. The second rank, rank 3, when interacting with GRE is significant, as well as the third rank variable, or rank 4, when interacting, which means that the higher the rank in GRE, the higher the chance of getting admitted into grad school. So the assumptions for logistic regression versus linear regression are quite different. In my dataset's outcome variable is measured on a dichotomous scale, which satisfies the first assumption. And the second assumption is that I have one or more independent variables which can either be continuous or categorical, and that the assumption is true, or that assumption is true regarding my data. The third assumption is that I should have independence of observations, and the dependent variable should have mutually exclusive and exhaustive categories, which is consistent with my data as well. According to David Freeman, regression models are not a good way of doing empirical work in the social sciences because the technique depends on knowledge we do not have, and those who use the technique aren't paying attention to the connection between the models and the phenomena that they're trying to study. So the conclusions may be valid for computer codes, but the claims are hard to transfer from the codes to the larger world. So this is particularly relevant to my data that I've chosen because GRE and rank of one's undergraduate college are both factors that are taken into consideration when applying for admission into graduate school, but are not necessarily the only factors that admission departments look at. Thus, it's hard to transfer these results to the larger world and conclude that GRE and rank are the sole predictors that determine one's admission into a competitive grad school. And that is my final say on the Module 3 and the end of my presentation.